Hello guys, my name is Ely Balbero and we're here to talk about what is an arithmetic sequence. So, let's start.
Okay, so first of all, let's learn what is a sequence. A sequence is composed of infinite numbers and ended with ellipsis, which represents infinite sequence. So, in every sequence, there are called terms. For example, this 5 is the ace of 1, 7 is the ace of 2, 9 is the ace of 3, and 11 is the ace of 4. So that is what we call sequence. Now let's move on to the arithmetic sequence. Well, an arithmetic sequence is obtained by adding a common difference. And common difference can be obtained by subtracting any two consecutive numbers. For example, 7 minus 5 is equivalent to 2. So that's how we get the common difference. You could also use the other terms. With this common difference, you could identify now the next term of the sequence or any of the term of a sequence. So for example, to identify the ace of 5, just add the ace of 4 to the common difference to obtain the next term. So, substitute 11 as ace of 4 and the common difference, which is 2. So 11 plus 2 is equals to 13. So the next term of this sequence is 13. Now here's an example. In this sequence, we need to find the next term of this sequence. So to find out, we need to identify first the common difference. And to identify the common difference, subtract the two consecutive numbers. So ace of 2 minus ace of 1. So substitute the numbers 6 and 3. So 6 minus 3 is equivalent to 3. So our common difference is 3. So the problem is find the next term. So the next term is ace of 5 because 12 is the ace of 4. So to identify the ace of 5, we just need to add the ace of 4 to the common difference. So let's substitute the problem. Ace of 5 is equivalent to ace of 4 plus d. So ace of 4 is equivalent to 12. And the common difference, which is 3. So 12 plus 3 is equivalent to 15. So is equivalent to 15. So our ace of 5 is 15, which is next term. Now we're up to the next example. So the next example is we need to find the next term of this sequence 7, 21, 15, 9, and 3. So to find out the next term, we need to find first the common difference. So common difference is to subtract any consecutive numbers. So for example, d is equivalent to 27 and 21. So 21 minus 27. So 21 minus 27 is equivalent to negative 6. So now we identify our common difference. So now we identify now the next term. And the next term is the ace of 6 because ace of 3 is ace of 5. So to identify the ace of 6, we need to add the ace of 5 to the common difference. So, example, ace of 6 is equivalent to ace of 5 plus d. So, substitute the problem 3 and then the common difference, which is negative 6.
Since 6 is negative and our operation is plus,
So, we need to substitute its operation and turn it into negative.
now let's subtract 3 to 6. So 3 minus 6 is equals to negative 3. So our ace of 6 is equivalent to negative 3. So that's how to solve it. Now, on to our next lesson. This is all about arithmetic formula. An arithmetic formula is being formed with ace of 1, which is the first term, n, which is the number of terms, d, which is the common difference, and ace of n, which is the nth term. So, here is our example sequence, which is 15, 24, 33, and 42. So, let's use this example sequence to find out the nth term. Like, for example, the nth of term is 10, 10th term. So, to find out the 10th term of the sequence, let's find out first the ace of 1, which is the 15 number of terms, which is the 10, and the common difference which can be obtained from the sequence. So 15 minus 24 is equivalent to 9. And the nth term, which is unknown. So to find out the nth term, substitute ace of 1, the number of terms, and the common difference. So to solve, put first the nth term, then substitute ace of 1, which is 15, then plus, then the number of terms, which is 10, and then minus 1, then the close parenthesis, and then the common difference, which is 9. So since n is equivalent to 10, we will change it into ace of 10. So simplify the formula. So let's bring down 15. 10 minus 10 is equivalent to 9, and 9 times 9 is equivalent to 81. So 81 plus 15 is equivalent to 96. So our ace of 10 in this sequence is equivalent to 96. So that's how to solve the nth of term using the formula. So, up to our first example. Find the 18th term of the sequence 2, 8, 14, 20, and 26. So, what to find in this problem is the 18th term, which is unknown. So, to solve the problem, let's identify also the ace of 1, the common difference, and the number of terms. So to identify, the ace of 1 is 2, and then the common difference, 8 minus 2, is equivalent to 6. And the number of terms, which is 18. So now, let's use the formula, which is ace of n is equivalent to ace of 1 plus n minus 1 multiplied by common difference. So let's substitute the problem. 18 ace of 18 is equivalent to ace of 1, which is 2, and then the number of terms, which is the 18, and then minus 1, and then the common difference, which is 6. So simplified, ace of 18 is equivalent to, so let's minus first the parenthesis. So 18 minus 1 is equivalent to 17. 17 times 6 is equivalent to 102. So just add 102 to 2. So 102 plus 2 is equivalent to 104. So the ace of 18 is equivalent to 104. So that's how to solve the first example. So that's it, guys. That is what about an arithmetic sequence is and how to answer problems. So I hope you like this video and it could benefit you to your future development. So that's it and goodbye.